Chapter 3, Lesson 2 of Advanced Algebra. I'm going to do a video here where I do 6 or 7 word problems, so you can watch as many as you'd like to kind of get the idea how to set them up. I'll help set them up. I won't solve them, so you can do that part of it, but just to give you some idea and some more practice at solving these word problems. So again, we're going to need to create a system, so we're looking at creating 2 equations as we go through these. Once we've written the information, then to solve them, we'll solve it graphically because that would be the easiest thing to do. And when we're applying them, we're really not interested in quizzing you or testing you and if you can do substitution or elimination. We have other problems that we do that with. With word problems, we're actually looking for the solution, so the quickest and easiest way to do that would be the way to go. And because natural or word problems don't necessarily come out even a lot of the time, the graphing calculator may be the easiest, but not always, but you can decide what you want to do there. So let's take a look at some of these problems, and again, you can watch as many as you need. I'm going to use my iPad here to kind of help out, or to help draw on here. So you're going to see me work my iPad here and try to do this at the same time, so we'll see how that works. Okay, so suppose you have signed for a bike-a-thon to raise money for charity. One person is sponsoring you at a rate of 50 cents per mile. Okay, so again, we talked about this earlier this year about when we see a rate in a problem, how that's helping us. So notice as soon as we see this, we have a rate, which is the slope to our equation. So we have an equation, y equals, and then the slope, remember, is the number, so that's 50 cents, and per mile, that's going to be my x value. Okay, so I have one equation that's 50 cents for every mile. It says each of the other sponsors is going to donate $15 no matter what. So that's going to be constant. So it doesn't matter how many miles I go, I'm going to get 15. So y, the amount of money I'm going to get, is going to be $15 no matter what. So I have my 2 equations. One happens to be a horizontal line, and one has a slope of 50. Now it does tell me here in the problem that it wants me to use specific variables, so I'm going to go ahead and change those now for my equation so I have it set up right. So D is going to be the amount of my donation. There's my dog. Sounds like he's getting a snack. And then I'm going to change M for miles. So D equals 0.50 M would be one equation, and then my donation of $15 would be my second donation. Notice one other thing here, that both of these values, slope values, are in dollars. They do have to be the same if I'm going to work in the same system. So this would be my system, and we're looking, that would be the answer to A then. And then for B, how many miles will all the sponsors donate equal the same? So I want to know when this donation at 50 cents per mile will equal this donation 15, so I can use that to go ahead and let me write that up a little bit nicer. So I can use that equation, so I can put this in as y1 on my calculator, I can put this in as y2 on my calculator, and again find the intersection. Or I could just very simply do the algebra for this, dividing both sides by 0.5, and that's going to give me 30. So the amount of miles when they're equal is going to be 30. Okay, on this problem we're looking at a youth group with 26 members are going skiing. And each of the 5 chaperones are going to be driving either a van or a sedan. And the vans can seat 7 people, the sedans can seat 5 people. How many of each type of vehicle would you transport? So in a situation like this, and again, this is a very common type of problem that you run into, it's actually giving you 2 ways to look at sedans and vans. The first way is how many sedans and how many vans are going to be used. Well, we don't know, so we do know though we're going to be driving vans and sedans. So we need to choose some variables, so we'll let our vans equal V, and we'll let our sedans equal S. Okay, so we have that. So now it says here that we're going to be taking 5 chaperones who are going to be driving these vans and sedans. So if we drive vans and we drive sedans, there are going to be 5 people driving those, so that's going to give us a total of 5 vehicles. All right, so that's one equation, how many people are going to go. The second thing that they tell us is how many can go per van and per sedan. Well, we're going to then use this V and S then to multiply it by the number of people that can sit in it. So the vans can seat 7 people. So I can get 7 people in each van. So if I multiply the number of vans times 7, that'll tell me how many people. That's right, it's 7 per the van. And we can fit 5 people in each sedan. So that gives me 5 people in every sedan. Then how many people total are there? Well, there's 31 people going. So now I have my 2 equations. So here I would use substitution or elimination to go ahead and solve that. Substitution might be an easy one to go with because you have coefficients of 1. Or if you multiplied by a -7, that would give the V's to be opposite, or -5 would make the S's to be opposite, so you could use elimination to do that. So that's how you would set that up, so you can go ahead and solve that one on your own. So in this problem, we're looking at which job would pay better. So suppose you have a part-time job delivering packages. Your employer pays you $7 an hour, but a competitor wants to pay you $2 an hour for every $2 an hour plus 35 cents for every delivery. So write a system of equalities to model the pay for deliveries. So my independent is going to be the number of deliveries that I make. So that's going to take my x value in my linear equation, and P is going to be the pay that I get. Okay, now it's important here to note that they're talking about a 4-hour shift, so that's going to be important when we're trying to compare these, because we're going to figure out how much you'd have to make in a 4-hour shift. All right, so to take care of the first amount of pay, we're going to get $7, and in 4 hours that's going to be $28. So in the first job, my pay is going to be equal to $28 for a 4-hour shift. Now, for the second competitor's pay, he's going to give me $2 an hour. So $2 an hour for 4 hours is going to give me $8. So he's going to give me $8, but in addition to that, plus he's going to give me 35 cents for every delivery. So this is going to be my equation. Now that's not slope-intercept form, but a little bit backwards. So if we wanted to write it in slope-intercept form, we just reverse those. So let's go ahead and do that just so it looks a little bit what we're more used to. So I'm going to get 35 cents for every delivery, plus I'm going to get $8 because I'm getting $2 an hour for 4 hours. Okay, so there would be my system using P and D, D representing deliveries, not the amount of pay I get, and P the amount of pay I get. So again, this is a situation where you can find the intersection, or you could use substitution, substitute this P is equal to 28, substitute it in, and then solve for D. One final example I want to help you with on this one is says that the measure of one acute angle of a right triangle is 30 degrees more than twice the measure of the other angle. Now, when you have a situation like this, we have two angles. Let's call them angle A and angle B, neither one of which we know the measure to. So both of these are going to be variables. So let's just use A and let's just use B for this so we don't have the angle marks in there, and that makes it a little bit easier. So we need to look at the way that this problem describes these, and we're going to need two equations, so there must be two types of descriptions in the words. Well, one is pretty straightforward here. It says that one angle is, so we'll take A as a one angle, is an equal word. 30 degrees more than, more is a plus sign, and then means I switch the order, so that's going to be 30. Twice the measure of the other, so twice B. So this is one equation that I have. So now I need a second equation, and this one is not quite as straightforward. It takes a little, remember that triangles, angles always add up to 180. We know it's a right triangle because it says that right here, so the last two angles, a right triangle has a right angle of 90. That means the other two angles, in this case A and B, must add up to 90 because that would equal the other 180. So angle A then plus angle B is going to equal 90 because they're in a triangle. So there's my system of two equations, and then again, this one's already solved for A, so I could use substitution, might be the easiest way to go. So I hope that was helpful for you working through some of these word problems, and we'll see you in class next time.